We are gathered here today virtually to kind of introduce students and several faculty to the Advanced Manufacturing initiative that we have going on in Greenville. And so this is intended to be a year-long cohort-based program, and the informational presentation that we put together is similar to what we've done in the past at other informational sessions, but we're augmenting it with a little bit more information and some updates on what people are doing currently. Not sure why that toggled off, but our first speaker, I asked Dean Gramapati to join us to give a little bit of introduction about what his big vision is for advanced manufacturing within our college and how this year-long program fits within that. So Dean Gramapati, if you want to unmute yourself, introduce yourself and give us a little short spiel.
I don't know what. First of all, good evening, everyone. I don't know what short is. Short in my world is a 30-minute speech, but I'm going to give it really short. But with that said, my background as a bachelor student was the equivalent of mechanical engineering. Coming from India, it was production engineering. Okay. But before I start that, can you all hear me clearly? Okay, wonderful.
Yes. Yeah, loud and clear.
Yes,
okay.
And nice birds in the background.
Yeah. So the picture on the slide and the picture of me, you can see, hey, yeah, we can change ourselves very quickly. But with that said, I'm excited about this program. I look at as an undergraduate student myself, and if I had to start my career and end my career in mechanical engineering at Clemson, what would this mean for me? A final year of an advanced manufacturing track. And I think I go back to what the CEO and president of BMW said to me. He said to me, Anand, we need top-notch engineers, highly motivated engineers who can think out of the box. Okay, who will not just think engineering, who will think computing, who will think social science, who will think human factors, who will think psychology, but who will be able to work in teams, who will be able to take in contrarian opinions, okay, people who do not agree with them. And so can you create a world-class curriculum in the final year of the mechanical engineering that can lead to something like that will graduate those kind of students with those skill sets? And guess what? Forget BMW, but other companies will be able to recruit those students. I said, if we graduate those students, let me promise you, Canute is the CEO of BMW. None of those students will remain at BMW. They will be working for Teslas of the world. Okay. And I'm glad to say that we have a cohort of students who want to join this program. But most importantly, what I see is, as a student joining this program, you will be taught by world-class teachers, world-class instructors. You will get an exponential learning experience. You will be taking tours of advanced manufacturing sites. You will be working side by side with other researchers. You will be working in an urban area in Greenville. You will be working at CU ICAR or at Clemson University Restoration Institute in Charleston. You will be interfacing with other professionals in the advanced manufacturing arena. And what that does for you is you will be absorbing from the best of the best. From Josh Summers to Mark Johnson, to Richard Figliola, to Atul Kelkar, who's going to speak later. I wish I was a student in this program, because not only I was a student in this program, because this program doesn't end after you get your bachelor's degree. You go out to work, you can come back and continue to get your master's degree out of CUI card. And the beauty of working at the innovation campus is it's a different location, it's a different site, it's a different environment, it's a different work ethos. It's almost semi-professional just before you go to work. And I think you will enjoy the experience. This cohort of students who wants to join this program, as we are going to, is what I call as a pilot cohort. A lot of students and parents have been asking me about this. How can my young daughter or young son spend time at the CUI CAR campus when they graduate out of engineering? And I think this program actually does that. And most importantly, you have Dr. Summers and Dr. Mark Johnson and Dr. Atul Kelkar and the faculty members in this program who are totally engaged and invested in making sure that not only you are successful in the program, but you have the skills that you can take and deploy them to be successful when you get your first job. Or you decide to go to grad school, not just here at Clemson. If you decide to go to Georgia Tech, or you decide to go to Carnegie Mellon, or you decide to go to UC Berkeley, being at CUI CAR and working with people that you will run into is a wonderful opportunity. I wish each one of you great success. And as I said earlier, the best thing that happens is you have a wonderful set of faculty members and colleagues who you can lean on not only during the program, but after you leave the program, who you can call up and seek advice, not 2, 3, 5, and 10 years from now. So wishing you all the best. I hope each one of you join this program. Personally, I live in Greenville. I'm totally vested in this program. Mark Johnson lives in Greenville. It's not a bad ride. It's a quick ride from Clemson to Greenville. At the same time, we are trying to develop a similar cohort down in Charleston, South Carolina. So, and the most important thing is companies, BMW, Michelin, Boeing, Bosch, all of them are looking at us and saying, we want to engage with these students as they come out and do projects. And I'm hoping some of you will not just take jobs, some of you will become entrepreneurs and innovators and create your own companies. So with that said, thank you for being over here. Thank you for joining us today.
Thank you. All right. So that was the dean who basically kind of spearheaded this idea, and then he foisted it on Mark and I to try to figure out what to do with this. So Mark, do you want to introduce yourself and tell us a little bit about your passion for advanced manufacturing?
Great, thank you very much. My name is Mark Johnson. I'm a professor in material science and engineering, as well as mechanical engineering at Clemson University. And I will attest to, as what Dean Gramapati just said, driving from here to Clemson literally is the shortest commute I've ever had in my life, even though it is, 20 miles. So it's just, it's nice in the area to be in this area. I'm going to try and cover 3 questions that you all might have. First is, what is advanced manufacturing? Why it might be interesting. Second is, how does manufacturing in this advanced manufacturing world fit in the global economy, and why does it matter for us here in South Carolina? And hopefully, I'm going to convince you that Actually, I-85 corridor, and particularly the I-85, I-26 intersection, really represents kind of ground zero for advanced manufacturing and competitive manufacturing for the entire nation and for the global economy right now. And then as a result of that, how this is a unique opportunity with the advanced manufacturing program. Clemson is the premier research university in South Carolina, and in particular here on the I-85 corridor. Really, it provides a great opportunity, and it's something you can both have fun doing, find rewarding in your life, plus it really provides a unique opportunity to contribute at a cutting edge place. So the first question to ask here is, what is advanced manufacturing? I define that simply. I mean, people get an idea what's manufacturing. You're making something. Turns out that 70% of all things that are developed or where there's R&D and that there's patents in it, where they ultimately find value is in making something. Without that, it's literally just a paper exercise. The manufacturing part of it is where you take that idea and have something tangible that you result with that you can then provide to your friends and neighbors and everyone else around you. And it's making things. So what is the advanced part about it? Well, it's where to do that well and to do that competitively, you're using technology to its fullest advantage out there to make it so you can wind up competing as well as possible. So if you were in Germany and we were talking about the exact same field, everyone would call it Industry 4.0. And if we were in Japan, you'd call it the Robot Revolution Initiative. And in fact, we all wind up working together, and it's a similar set of things that range from things like robotics, 3D printing, advanced data and analytics, composite and advanced materials production. It's where you have systems design and how you can actually make those systems and how that interplay works together on it. It's also really important issues of sustainability and energy. So how we can wind up making the things we wind up using, but also use that as effectively as possible. So all of those things come under the broad area of advanced manufacturing. And also because of that, as I went through that, the advanced part means that not all of those jobs are going to be in what you call the manufacturing sector. It's estimated that between a quarter and a third of all the jobs that are in the information technology sector only exist because of advanced manufacturing. So if you're working for a company called SAP or SAS or even Deloitte and McKinsey as consulting companies, guess where the majority of the work they wind up doing is? It's for the manufacturing sector. It's taking that data. And in fact, this ties to my second point, which is to say this area is ground zero for advanced manufacturing, particularly in the United States. So all those folks that are working at the Stanfords and MITs of the world where they're trying to do advanced data analytics and artificial intelligence, they need data. You know where they go to get that data? They come to South Carolina. They come to places where you're manufacturing things because that's where the information technology and the real application gets found. And you're already there. And so you can wind up doing that research by working together in that area. And the point that this is the leading place in the world for advanced manufacturing, just highlight, as Dean Gramapati just mentioned, BMW being here, people think of that as being sort of a recruitment of a BMW plant to South Carolina. That is BMW's largest plant in the United States. And the second point is it is the largest automotive exporting plant out of the United States, factory out of the United States of any automotive manufacturer. Automotive being one of the largest manufacturing sectors. That says that our competitors on that are not South Carolina versus Detroit, because that's for the 30% of it. It's how do you wind up making those cars cost effectively so that those 70% of them are sold overseas against cars that are made in Nagoya or made in Stuttgart, or they might be made in England somewhere, or wherever they're making cars right now that they would be sold against competitively. And in fact, 20% of those cars are sold in China. So think about that. A German company recognizes that investing in South Carolina is the most competitive way to make things for the Chinese market. That's good for all of us. And what that is, it's because this is the place where that technology gets inserted, because it's not that it's lower cost jobs and low wages. It's saying it's the place where the technology takes the greatest advantage. And why has this then become a unique opportunity? To my third point on this. Well, what Clemson's put together here, if you go to the ICAR campus, and I encourage any of you that want to come visit there, COVID opening rules aside and all that sort of stuff, be happy to wind up showing you around. It's often the place on I-85 you drive by where you go, oh, there's that orange Clemson sign. I think they do automotive research there. You have computer science research, you have mechanical engineering research, you have automotive engineering research there. You have an entire industrial park of companies that are popping up to be in that ecosystem together. What Clemson's put together is a program where you have all the way from PhD students and advanced companies that are doing research in areas, working down with undergraduates, working with even community colleges, where there's a community college right on the site there, working on the entire suite of technologies that are needed to be used out in the marketplace. I will say I was on a call last week with colleagues in Germany, and describing what we've set up at ICAR, they said, and we think of Germany as being advanced, they said, we could never do that, what you've described there, in the German system. The US system, and in particular, what you're doing at Clemson is literally the only place in the world where that can be done and where that's being done effectively. So you as a student actually have a globally unique opportunity to take advantage of this. How we're integrating all of the engineering that you wind up having. The interesting things about why you became a mechanical engineer in the first place. It's your creativity. It's your interest in design, your interest in curiosity about the things that are around you. And how do you wind up then manifesting that and using that to build not just what your job's going to be, what's your career, how this is putting you on a pathway. So we want you to be that 21st century leader and keep moving forward. So the details of that, I'm certain Josh can wind up sharing a bunch of that with you. This is the why, and this is how this is so unique as an opportunity for you. So thank you very much, and I'm available anytime you want to talk about this. And with that, Josh, turn it back to you.
Thank you, Mark. So our third guest is Dr. Kelkar. He is the Department Chair of Mechanical Engineering, and we've asked him to explain a little bit of how this fits into the department's vision. Dr. Kelkar?
Yep. Thank you, Josh. First of all, welcome all students and faculty as well who are present for this today. Thank you for attending. So I'm going to kind of follow on what Dean Gramapade and Mark basically, they already made a compelling case for why manufacturing is so important. But I'm going to now add to that as a mechanical engineer, okay, why you should be interested in this and what mechanical engineering, what role mechanical engineering plays in manufacturing. And that's why I'm interested as a chair in my department to really get focus on growing this manufacturing emphasis for our students and to make them a commodity which is rare commodity in the market. Okay, so you'll say, oh, there is a manufacturing engineering, there is industrial engineering, there's mechanical engineering. What is this advanced manufacturing part playing in the mechanical engineering? So first of all, the ME degree is sitting at the core of manufacturing engineering. ME typically, the core ME degree typically focuses on designing machines or systems, doing some analytical work that supports manufacturing processes and methods, whereas manufacturing engineering by itself is focused on actual manufacturing and production processes and operational aspects of that, right? So by choosing advanced manufacturing emphasis in senior year, we are trying to make you a complete package that industry is looking for. Because now you have both your mechanical engineering core that you need for manufacturing, and then you get that senior year advanced manufacturing emphasis, where you will get those other training in other areas like what Dean talked about and what Mark talked about, is touching some computer science expertise that you need in manufacturing, because we are talking about advanced manufacturing. So it's not traditional manufacturing nowadays. So you need to learn some interdisciplinary areas, how they play a role in manufacturing, and that's that additional know-how and training you will be given in this particular program, right? And again, this program is really came about with industry asking for it. That means they are also driving this, hey, please have produce students for us who have this kind of multifaceted knowledge. And so obviously, when they are asking for it, when you have that knowledge, you are going to be a hot commodity for them. Okay. Now, there's another angle to this now. In fact, if there's a silver lining to this big pandemic crisis that we are in, and this post-COVID-19, there is going to be huge spike in manufacturing jobs as in US, because several OEMs and their supply chains are bringing manufacturing back to US from China and other countries as well, because they now suffered a big setback with their supply chains right now. And many of them, a friend of mine actually works for some automotive companies and some pharmaceutical companies, and they already said that they're already bringing some operations back in states. And that means there will be a great demand for manufacturing sector jobs. Okay, so you will say, oh, okay, that's a manufacturing sector jobs. How does it translate to mechanical? So if you go to US government, the Bureau of Labor Statistics, you can actually verify what I'm saying. There are about 290,000 to 300,000 ME jobs in US, and more than 50% of those jobs that mechanical engineering, therefore mechanical engineering, are in manufacturing segment. Okay, so this data should be convincing for you all, if nothing else that we talked about convinces you. Okay, ME department per se is really taking steps to streamline our syllabus, especially elective choices, to incorporate several of manufacturing specific courses as they are developed. There are new courses are being developed by our new faculty, as well as Josh, and is collaborating with many people. There is some other NSF grant activity that is creating new courses, and that gives these courses we are trying to get into our approved elective courses so that the students have maximum flexibility in their course choices. We are also trying to figure out ways to take advantage of technology for our course delivery to maximize choice for students in choosing courses or instructors. We are trying to work with CAM to establish a more specialized manufacturing-centric capstone program that is much more richer in industry engagement. That is the advantage of being on that ICAR campus, is not only the state-of-the-art manufacturing labs they're building, but it's the involvement of industry and actually industry personnel's interest in that facility to create some kind of highly enriching capstone program that you will be a part of. I also want to talk about another sector that is getting a lot of growth right now, and that's because of the energy, renewable energy focus. A lot of investment by federal government in renewable energy, and that's another emphasis area for our seniors, and that's for Dr. Figliola's camp there in Charleston. That again is a very strategic location because of the industry over there. But I can tell you personally, in last 6 months, I've been helping Advanced Research Agency for DOE, where Mark came from, on some exciting, reviewing some exciting programs that they are, and they're coming up with and investing in. These are like the wind turbines which are floating on the sea. They're also looking at extracting energy from flowing water in the tidal waves in the sea, as well as in the riverines. So there are a lot of exciting things are going on in the energy side, and that is another sector where they're going to look for jobs from mechanical. I mean, there's people from ME background. So that's another program in senior year that you should be thinking about. So I just wanted to, I don't want to take a lot of time about other details you're going to hear from Josh, but this is really something that you should think about seriously, and I hope you take advantage of this, because this is going to distinguish yourself from everybody else that's going to compete for these exciting jobs when you graduate. And this program puts you on the top of that pile. okay, of the resume. That's what you should be. That's why you should be choosing this program. With that, I'll let Josh take over. Thank you, Josh.
Thank you very much. So from here on out, if any of you have questions, please feel free to interrupt. We can either do the raise your hand, and I'm going to ask maybe Mark to help interrupt if you see a hand go up and I don't see it, or go ahead and unmute yourself and ask a question. But in terms of this program, it's been 2 years, 3 years in the making. We've spent some time gathering some information and some understanding from companies, as was mentioned before, and this will actually be the second year of the cohort program. So last year we did have 10 students that completed the program, and I'll introduce you to those students a little bit later. Also, we're going to be introducing the other two lecturers, Brian and Geeta, in a little bit later, so that they have a chance to introduce and show you who they are. So in terms of the motivation, Mark really tried to dance around this. What is advanced manufacturing? And we've been struggling with this. And if you go and look at definitions, you'll get a definition. So what do you do? First time you have to define anything, where do you go? It used to be you went to the encyclopedia. Now we just go to Wikipedia. And so Wikipedia tells us that advanced manufacturing is the use of innovative technology to improve products or processes. Well, poop. That doesn't really tell me very much. So what is manufacturing? Manufacturing stretches all the way from material manufacturing, where you might have mechanical or material science, chemical engineering, electrical engineering, computer science. All of these disciplines will have some impact on material manufacturing. And then you can move on to part manufacturing. And there it's more mechanical, industrial, electrical, computer science. And then finally, you wind up in assembly manufacturing. And so we are focused for the first few years primarily on part and assembly manufacturing up here in the program. Much of this is driven by some of the local OEMs or original equipment manufacturers, and how assembly is this intersection of engineering, human, and computers. And so a lot of the courses that we are offering, a lot of the projects and the programs and the labs are centered in and around that. So that is kind of the definition that we're working with. But this wasn't really good enough for me. So I guess it was last year, we had a workshop. And this workshop was with, I don't know, Mark, we had what, 30, 40 companies from the upstate, focused on lots of different things. Part of it was working on the PLM Center with John Wagner. But I pulled aside probably about 20 participants and I asked them to give me the definition of advanced manufacturing. And these are a few of those definitions, and I'm pulling out a few of the key concepts. New technology, improve, new technology. They want to move from tribal knowledge and gut feeling and move into more of a digital. So again, new technology, latest technology, looking to tomorrow. So they're not really telling me very specifically what advanced manufacturing is or what we need to be teaching students. So moving on, I said, we've got to find a better way to understand what they need. And so we asked them to give us what the KSA is, what the KSA are, sorry about that. So the knowledge, the skills, the abilities that they're needing in the next generation of engineers. And we had a list of these, I call them hard skills because they're difficult. Others call them soft skills because they don't know how to define them. But stuff like endurance and persistence, communication, flexible thinking, professionalism, self-awareness, all of these are kind of characteristics of people that the companies want. And if you individually go through and you see, or you do a self-assessment, where are you? Do you take initiative? Are you excited about solving problems? Do you find that you're fearless and confident and willing to fail, willing to try? And then we also have the knowledge, the coursework. They listed out topics like lean and manufacturing processes, current and future, additive manufacturing being one of those. Business knowledge, automation, social, cyber, physical. So these are some of the things that they're looking for. But again, it's not really crystallizing. So we asked them in a third activity to write a job ad. And so we set it out into 2035, so 15 years in the future, and said, what is that job going to look like? What are the characteristics that they are seeking? So some of the characteristics are passion for discovery, absence of the fear of trying, communicates well, leadership, supports others. Okay, so these are great things that are very difficult to teach in a textbook, but they are things that you can teach and you can reinforce in projects. And you learn this through team activities and through doing. So some of the duties that they identified were programming. They want students to have an understanding of programming, data structures and languages. Not that they're going to be programmers, just that they have a knowledge of, so that they can be conversant with others. A experience with microelectronics, Raspberry Pi and Arduinos. The ability to collect and interpret data, and even looking at big data. How do you navigate that? What do you do with it? So one of the interesting things, whenever we talk to companies, every company is very excited when we talk about big data, because they are collecting volumes and volumes. We're talking petabytes of data on a weekly, if not even daily basis in the manufacturing process, and they just don't know what to do with it. But the last 2 points here are the 2 points that I found most interesting. They are looking for engineers who are able to mentor and guide technicians, be able to work with former students from technical colleges, people that have associate's degrees. They also want their engineers in advanced manufacturing to be able to develop training workshops for other engineers. And so starting to scratch on that a little bit, I'm asking, what do you mean? Well, they want their advanced manufacturing engineers to constantly be going out and finding new technologies, new ideas, new things, maybe from trade shows, maybe from trade journals, from journal articles that they're reading. But if you go out and you find a cool new idea and you come back to the company and you keep it in your own head, it basically does no one any good. They want the engineers to be able to teach others. So this idea of being able to teach, not just train, but teach others about new things, is a key aspect of the future of the engineering profession. And it's something that you will not find, that I found in any of my visits to all these other schools for ABET. So in terms of the program status, I want to briefly touch on some of our objectives and benefits, and then we'll move on to more details. But our overarching program objectives are to provide ME students, and it's ME students for right now. I'll talk about our expansion plans later. but provide them with a unique, interdisciplinary, project-centered experience focused on advanced manufacturing. We will incorporate both local and global industry, technical colleges, and graduate coursework. Provide a scientifically rigorous research training in advanced manufacturing. I'll come back to this also. Be recognized internationally as a premier program for education, and be recognized internationally as a unique platform for educational pedagogy and organizational experimentation. So one of the great things about this is that we have an approach that will allow us the flexibility to try out new things and to try to break the old molds. But here I have highlighted in orange, provide scientifically rigorous research training in advanced manufacturing. This is coming from my own personal passion to make sure that every student understands what the possibility is in terms of doing graduate work. We spend a lot of time individually with the students in the program, working with them to figure out what their future, their goal, their passions are in terms of engineering. And we look at how those passions can be enhanced with graduate studies. And we spend a lot of time with them trying to identify possible research topics. So we don't want it to be a coursework only master's program, because that doesn't really fundamentally change how you think. We are introducing you to research now during your senior year so that you can continue, if you want, and most of them actually do want, to continue in graduate research. So some of the more detailed execution, we're using facilities at One Research Drive. In fact, I'm sitting up here right now. We spent the day with Mitra, who's a TA, Kick-Ass's top TA this year. Go, Mitra. And she is working on developing a series of custom labs for ME 4440 that use the equipment up here. And today she was working on path planning robotics with the Roomba prototype systems. So we have a series, I don't know, 5 or 6 of those. And she was working on CNC routers to verify and develop a lab module around that. So we have facilities here. We have access to facilities in the Campbell Graduate Center. We have facilities over with the Center for Manufacturing and Innovation, where the Vehicle Assembly Center, the Lane Mears and I run. And then we also have access to the GE Advanced Manufacturing Works pod. And we'll talk a little bit about that and a unique partnership that is being approved as of like right now. So we partner with manufacturers locally, and we try to have at least one large project course sponsored by a company each semester. So last year we had a project in the fall that was focused on needs from BMW, and in the spring we actually ran 2 capstone projects with General Electric, GE. There is a possibility to complete the advanced manufacturing certificate. So far only one student has completed it. That was Chip. And the reason that that's a little bit of a hiccup is because the offering for the 3800 was tied to the international component. So we're working on re-envisioning that and working with Molly Kennedy from Material Science on that. More importantly, we have the ability to complete a master's degree in 1 additional year, and that is focused on industry theses. So planned topics that the students define, the students own, and oftentimes based on some of their early collaborative projects and interests. So some benefits to students. The dean and Mark have figured out a way to introduce scholarships. So we have $2,500 scholarships for students that are participating. It's $1,250 for the fall and $1,250 for the spring. The classes are all small. And last year we had 10 students that completed the program. And we also have a graduate program, the Thinker program. It's a fellowship program that introduced another 10 students in some of the technical elective classes. So 20-ish students in the classes. We also have, since it's cohort based, we're able to try to ensure that the projects are integrated and span multiple classes. And I think Geeta will talk a little bit about that. Projects, industry sponsored, we're definitely focused on industries to the point where we reserve Wednesdays for our industry day. That's where we go on factory tours, or we do workshops with companies, panels, and stuff like that. The faculty, we have 2 dedicated faculty, Brian and Geeta, who are both coming from industry. And we are working on trying to figure out, and this is still a trying part, but a shared load where we're trying to move to the point where everything can be team taught so that the faculty that are in the program understand what the other faculty are covering. So we actually are working towards a balanced workload so you don't have all of a sudden 8 projects are due in 1 week and nothing due for 2 weeks. We want to make sure that we're building on lessons learned. The program is definitely experiential. We look at trying to find external mentors. We integrate you on the floor, the facility, with graduate students. So there are graduate students that are doing their research here. There are industry that works 1 floor below and 1 floor above. So a lot of networking. A lot of the focus is on teamwork, leadership, and professionalism. So you might have noticed I've been referring to all of the faculty by their first names. And that is something that we want to build into the culture here. So when you set foot on the 2nd floor, you are a colleague. You are a peer of the faculty. So you don't call me Dr. Summers, you call me Josh. You don't call, I mean, it's Brian and it's Geeta, okay? Just like when you go out into industry, you don't call, I mean, Ryan doesn't call Stephen O'Shields Mr. O'Shields. She calls him Stephen, okay? So, and then the last aspect, and I know I've talked about it, and I will keep talking about it, is research. We spend a lot of time in the 1st semester and the 2nd semester doing individual mentoring with students, helping them understand what research is, how to identify problems. So solving problems is what you learn as an undergrad. Finding problems, asking the right question, that's what you learn in grad school. And that's what companies are desperately seeking. So in terms of the broader vision, we are looking for integration. We want to integrate disciplines. Right now, we have mechanical engineering, but in 2021 and moving forward, we're looking at rolling this out and integrating other disciplines like material science, industrial engineering, computer science. There is a graduate program in computer science that we share the floor with. And so we're hoping to be able to have more advanced manufacturing focused data analytics classes taught through them. We have interdisciplinary technical electives like the teamwork in manufacturing class that I developed and taught last year. We want to integrate courses. So how do you have one project that spans ME 4010 and ME 3020? We also have the future possibility to look at splitting classes into single unit credit modules, or even combining them into 6-credit mega courses. And so we have that flexibility because we have a cohort mindset. We want to integrate industry as clients on projects through factory tours. We want to integrate research, that BSMS option. So if you have a 3.4 GPA on main campus, you can get accepted into the BSMS program, which allows you to, in mechanical, take 4 technical elective classes as an undergrad and as a grad. So it counts both ways. Well, we petitioned a couple years ago to allow us the flexibility to be able to extend that to students with a 3.0 GPA if they're participating in the program. So you still have to petition Dr. Joseph, who's the Director of Graduate Studies, and he has to approve whether or not you will be accepted to the BSMS program if it's below a 3.4. But there's that option, and that allows you to accelerate and get half of your courses out of the way. Definitely looking at research inspired based on tours and industry discussions. In fact, several of the students are staying. That is where the research topics came from. We want to integrate education. So a lot of the classes that you take will be with graduate students. And we're integrating the Greenville Tech students through CMI with the idea of maybe bringing them in the fall to actually serve on design reviews in your class. So it's a flipping of how things go. So last year, like I said, was our first year, and this is a picture of the first cohort. They identified themselves as Novus, meaning new. And that was one of the first activities that we wound up doing. I'm going to briefly introduce Brian and Geeta, but in a little bit, they'll each talk about different aspects and they'll introduce themselves a little bit more. But Brian is coming to us from industry, 29 years of experience, and then also about 6 years of experience in academia. Geeta is a little bit younger and is a little bit more frazzled with young ones at home, but she comes with experience in industry. And there we go. Sorry. So Brian, do you want to take over, unmute yourself, and I'll go ahead and advance for you?
Sure. Hello, everyone. My name is Brian, and thank you for spending the time to learn more about this program. It is a unique opportunity that Clemson University, the state of South Carolina, and many have invested in for the future of manufacturing. And as you've listened to individuals before me, I'm sure you've pulled out various keywords such as innovation, global, value, manufacturing, education. And so what I'd like to do in the next few minutes is just basically run a thread through all of that in terms of 3 points. One, these tours are designed, dedicated, and totally for the purpose of your touch and feel. And as engineers, we know that touch and feel is very important in terms of application, in terms of being in the real world with respect to, how is it actually done? Where are the pitfalls? How are solutions obtained from a team standpoint? When is a product ready for full-scale production? How are we ensuring that the requirements are being met that the customer expects? What happens when the customer changes their mind with respect to the end product? And so these tours, as Josh has already indicated, are set up for Wednesdays, and we work really hard to ensure that everyone's schedule and responsibilities map out in such a way that Wednesdays are dedicated for plant tours. Now, the logistics of how we travel, lunch, meeting, and so forth, we work through those beforehand so that everything runs smoothly. And I'll just point out a couple of experiences here based on this slide. For example, you heard Mark talk about BMW. You know, BMW is the largest exporter of vehicles from the United States. And with the M series, the I series, the X series, the Z series, those vehicles are only made at the BMW plant in Spartanburg. And we had a great opportunity to tour this plant with students from Dr. Mears' class. And what we observe, and as you would probably discern, that there is a large degree of robotics and automation in a plant that's producing more than several thousand, probably close to 500,000 units per year. And so the need for engineers that are innovative, that can quickly come up to speed with what currently is working and how can it be enhanced in terms of cost savings, in terms of human interaction, in terms of incorporating new technology. We really got a good insight as a result of that tour. Michelin in the lower left-hand corner. We had a wonderful experience touring 2 of their plants over in Anderson. And it's quite intriguing and exciting to see how tires that are 12, maybe 14 feet in height, how those tires are manufactured for earth-moving equipment. And for me, one of the most intriguing statements with respect to manufacturing and producing tires is the performance of the tire is in the chemistry of the rubber. And so if you'd like to talk more about that, that's an opportunity to give me a call, or let's have an offline discussion with respect to how the chemistry is in the tire and what that means with respect to manufacturing earth-moving tires. Just one other point with respect to this slide, you'll see us standing in front of the Greenville Convention Center. And just to emphasize the point that Josh made earlier in terms of collaboration and listening, if you will, to each other, one of our students actually saw the email or the advertisement for this trade show that was being held at the Greenville Technical Center in the upper right. And we all adjusted in such a way that we were able to register and spend 4 to 6 hours at that technology show. Companies from all around the world exhibiting machines, technologies, and opportunities that support manufacturing, depending on what the application or what the product is. So, Josh, if you would advance, please. Just to continue with my second point here, these tours are intended and designed so that, yes, we do sit in class, we do have homework, we do integrate concepts across courses and so forth, but these tours are to support, solidify, and allow you to connect the concepts that we study in manufacturing processes, that we study in additive manufacturing or controls. And so when you go out to BMW or when you go to GE Power and you see PLCs or you see how they're changing the line in order to achieve greater productivity and throughput, you know, it's one thing to study and read through that in the textbook and have class discussions, but when you actually are on the plant floor and you're talking and listening with the experts, it really drives home the concreteness of this program. And then lastly, careers. You know, as you have an interest in manufacturing, indeed, you may move toward manufacturing in terms of your first career stop. But you may have an interest in forming your own business or becoming an entrepreneur, or you have an idea for a new device or system, you now have, and you want to start your own company. And the value, as Mark pointed out, the value is actually in fabricating or making that in such a way that you're going to be profitable, in such a way that you're going to add value or solve some concern in society that makes things more convenient or more safe. Well, having come through this program, having been on tours, having had the exposure to individuals with many years of experience and the appropriate background, you're now in the sweet spot and you're not inhibited to go out and do exactly that. And as engineers, that's a big part of what we do. So these tours will allow you to hone your interests in terms of what exactly within a particular sector of manufacturing you would like to work in. Graduate school, I'm a big proponent of graduate school. Getting your interests sparked with respect to the coursework, capstone projects, customer interactions, and so forth would perhaps spark that graduate school interest. And, as being pointed out, the program is closely coupled with the opportunities and the funding and the support for graduate school. So I'll end here, but I would like to offer to each of you a standing invitation, as been pointed out in many of the invitations, to contact any of us with any questions or even concerns or thoughts that you may have with regard to this program. So thanks for attending, and Josh, we'll turn it back to you.
Thank you, Brian. So at this point, I was going to turn it over to Geeta to talk a little bit about some of the other extracurricular activities that occur within the program. Specifically, maybe she can talk about the Design to Manufacture project. Geeta, can you unmute? There we go.
Yes, I have unmuted myself now. Hello, everyone. I hope you can hear me okay. My name is Geeta Chimata. I'm one of the lecturers with the Center for Advanced Manufacturing. Josh briefly introduced me earlier in earlier slides. So I would like to give a little bit of background information about myself. I did my PhD at Iowa State University. I graduated in 2016, and immediately after I started working in a startup in Las Vegas. It's called Imatrex, and it's a startup which does X-ray based medical equipment. I was hired as the first and only mechanical engineer for that startup, so it was really small then. And immediately after my graduation too, so I got to learn quite a lot of stuff really fast because I was forced to. But I think it provided me with a really valuable experience, which I'm willing to, and which I'm really enthusiastic to share with my students in the classes. So that's about my work experience, and then so I worked there for close to 3 years before moving to Clemson. I started at Clemson last year with the Center for Advanced Manufacturing. So have been here for a year and really enjoyed my 1 year at Clemson. And I'm looking forward to a newer cohort, so along with the existing cohort, to a newer cohort in this program. So that's a little bit about myself, and now I would actually like to talk about a little bit about what we do in these classes. So far you have heard from Dean Gramapadhyay about the motivation for this program, Dr. Kelkar about what this offers, and from Josh, Mark, and Brian, and more details about what is it that we are offering. So what I would like to cover here is how is it that we are actually bringing all those aspects to the classroom. So starting with so you must have heard from Josh about what these things that the companies are looking for. You have seen, oh, leadership, initiative. We want people who can actually teach other people. So how is it that you're learning these skills in the classroom is what I want to talk about. So I taught 3 classes, 3 courses, and I was also part of the capstone design as an advisor. So here on this slide, you can actually see our students who are in my ME 4010 class doing so it was a project. So it was one of the projects which they tackled in 4010. So 4010 is your introduction to your capstone. So to fulfill your capstone requirements, so 4010 teaches a methodical design process to achieve your design goals. And we did a little bit of practice with the projects in our 4010 course here in Greenville. So it's one of these projects. The students were working on making, so the problem statement we got was there was this conference happening on campus, and they wanted a memento which would be given to the participants in the conference, and they approached us with their problem, and the students were given freedom to come up with what that memento is going to be. So we used multiple steps in the design process to come up with what that item is going to be, and to the part where they actually made it and delivered everything on time. So they ran through the whole gamut of all the design and manufacturing related process right here. So this was a project that was both in 4010 as well as in Brian's 3120, which is manufacturing process class. So that once again shows you how the integration which Josh was talking about earlier, how we integrate the same projects into multiple classes. So this is how we did it. So all the design part was going on in my class, and then all the manufacturing side of it was being tackled in Brian's manufacturing class. In the design class specifically, so the students came up with these coasters. So we were talking about multiple things engineers have to keep in mind when they're designing stuff, and one of the things is sustainability. So that is where these wood coasters came to. So they wanted to make something which the participants are going to use, and that is also a sustainable option, environmentally friendly, and that's how you have these wooden coasters you see in the pictures. It was hectic for the students, especially when they had to deliver, but that was a good lesson, I think, in deadlines and timelines, and students were also successfully using stuff like Gantt charts, which you use in industry to keep track of projects. So they got practice on that before they moved on to their capstone in spring, and actually, so they got to practice here, and they were able to successfully implement stuff again in their capstone. So that's about 4010. That's one of the courses, and the other course I was really excited to talk about is additive manufacturing, which I was teaching in spring. So once again, that's one of the things which you must have heard industry people are looking for, new students with the knowledge of newer processes, and additive manufacturing, I should say, is at the top of the list nowadays because, people say complex design, and they were like, oh, you know what, why can't we 3D print this? So this is the course where we tackle that question. So what can we 3D print? Can we 3D print everything? Or when should we actually 3D print stuff? When is it economically viable? And all that. It was a really interesting course. So it's not just about learning the cutting edge stuff. So in the class, we used to look at the newer products that are coming on market. And so students used to watch videos before the class, and then we used to have these discussions in the class on how this equipment works. So what is the technology behind it, and how does it compare with the other conventional technologies that are already existing? So really everything that is actually going on, and you come to class and discuss about it and also learn in the process. The other thing which Josh was talking about is research experience that you would get. So as an undergrad, how is it that you're actually doing some research? So that is something else we tried to incorporate in this additive manufacturing class last semester. We started with the goal of actually having a conference publication. And students in my class, I'm really proud to say that they did a wonderful job in coming up with the topics with an experimental methodology. But unfortunately, because of COVID, they didn't have access to the equipment to finish their experiments and have that publication out there. But we got really close, so that's one thing. Publications, plenty of opportunity to have that, and also the research process itself. So in the class, we were able to talk about, what is literature review? That's the very first step in the research process. But how do we do it? So we used to talk about it and then actually practice it by doing these assignments, which would lead to the problem statement, which in turn would lead to the conference publication, potential conference publication, which I was talking about. So those are a few things which I think would set this program apart in the way in which the classes are actually dealt. Actually, these are the things that would, these are the new things that would actually get me excited to come to the class every day. You know what? Oh, I'm going to try this new thing, and my students are seeing my students excited about those new things is what drives me. And and once again, in the classes too, I think you get plenty of leadership because once again, you're doing this research. There is a leader. It's a group project. Those are a few things that we are doing in the classes. Apart from that, I know Brian touched a little bit upon the tours. So what do we bring from these tours into the classroom? A few things. So first I want to talk about 4010. So we went, our very first tour we went to is to Club Car in Georgia. And they showed us their entire design process. So they're making, they make golf carts, and if they're making a new golf cart, where would they start and how would it end? So very big, from the market surveys to how a product comes out. It was really good for the students to actually see that. And then every time we touched upon a new topic in our 4010, about different stages of design, we would be able to like go back to that example and actually discuss. So it was really good to actually see the live examples from the industry that people are actually implementing, and then talk to them about that in the class and how we could implement them for our own projects. The other one is Oerlikon Additive Manufacturing Tour, which we took in spring, at the same time as when we're doing the class. So it was really good for the students to actually see metal additive manufacturing in industry. Typically you only get to see the videos, but then here you can actually go see how it actually takes place and hear from industry people. So what are the problems that are faced, say, for 3D printing of metals at large scale? So it's definitely different from reading in a textbook because you can actually see what the problems are and how they are solving. So there might be techniques which didn't even get into textbooks that you can actually get to see. So those are a few things I think that actually, few experiences that would actually set this program apart. And for you to be part of those experiences, I think once again, that would put you at the top of that list, which Dr. Kilker was talking about earlier, as a candidate for the industry. Okay, next slide, please, Josh. Okay, I would also like to talk a little bit about the facilities we have. So we have our own dedicated lab on the second floor of One Research Drive. And here is a list of equipment that shows what we currently have, but it is an ever-expanding list. For example, when I was teaching the additive class last semester, we were getting this equipment related to each of the additive process as the class is going on. So you know what, we learn about this in the class, you see a video, and then we actually have it in the lab, so you can go work on it, print stuff. So we have a stereolithography machine, and we have an FDM machine, and we're also planning on getting the other stuff there. We are planning to set up a new metrology lab, which is related to the measurements. You see, once you, if you want to go into, say, a manufacturing job, you'll see how important measuring stuff is. You think you're making something to certain dimensions, but you have to ascertain that that is the case. So in line with the program goals, we're also developing these new courses, which actually fit with what people are looking for in industry, say. So this metrology course, which will be coming up in fall, it has GD&T aspects combined with the metrology, for example. The other facilities, the general facilities, so the classrooms are equipped with really world-class equipment. I think I would really like to say that we have the most maybe advanced classroom here on Clemson, in Clemson. Also, you actually get to have a really work-like environment, as in you have your own cubes and everything. So it's not. So that's where having that industry feel, which Josh was talking about earlier, you could see that too. So you have a professional environment. We have a shared kitchen where you can sit down. So it feels really office-like, really startup-like, as opposed to a campus. So I really hope you guys would visit at least once and see what we have here to offer. Okay. Next slide, please. Here are the courses that we're actually offering in Greenville. You have already, it must be clear by now that you'll be doing your final year. So here are the specific courses that you can get to take here as an undergrad. So that's 3120 manufacturing, 3060 machine design. So those are the 300 level courses, and 4010 design, 4030 controls. I think Dr. Summers might have actually a little bit more information about the curriculum aspects of it. About the offerings, but we are striving to offer new courses. So this fall we are actually doing global manufacturing that will be taught by Brian, metrology with GD&T. So that will be taught by me, and material selection that's going to be online. So those are a few things which I had to share with you. And once again, as Brian mentioned too, feel free to get in touch with any of us if you have any questions at all. And thank you for your time.
Super. Thank you, Geeta. So we have completed our first year. And one of the things that I wanted to be able to share here is what people are going to be doing in the fall. So we have 4 students that are continuing in the fall, focused on BSMS industry theses that they built out of the program. There are 2 other students that are continuing in the with their masters. One of them is going to continue. I don't know if he took the position offers that he got from other schools, or if he's confirmed to stay at Clemson to work with Dr. Schwann. And then the other one is going to be working on his master's in automotive engineering. But Jasmine got really interested in this idea of digital twins of humans, specifically for assembly associates, that moves well beyond the physical kinematics and kinetics of Jack, and includes stuff from the cognitive side. And so she is going to be continuing in the fall as a thinker fellow. So this is one of our NSF graduate fellowship programs. And so she's going to be getting a $34,000 stipend to work on the project, on her project of her choice, and join the Thinker Fellow. We have Sully Carpenter, who is very interested, and he got interested at the very first tour with Club Car on looking at why and how different companies automate their material handling. And how does that influence and impact their ability to reconfigure assembly lines and their ability to be able to handle mixed models? And so he's going to actually be continuing his master's in industrial engineering with Dr. Kurz. And he's also going to be a Thinker Fellow. Lucas Morand, he got interested in metal manufacturing, metal additive manufacturing in the fall. And then when he was working on a project in the spring for General Electric, looking at how do you design the support structures for these parts so that you can relax the internal stresses. And originally, as of yesterday, he was going to be a Thinker Fellow, again on the NSF NRT program. But after a conversation I had yesterday with GE, I think we have secured his funding for next year actually from GE. So he's going to be continuing that work paid by GE. And he's going to be working with Dr. Pataki on that. And then the fourth one up here is Meredith. And Meredith is interested in manufacturing change management processes. And I am struggling because I need to replicate her into 3 different projects. So I have lots of projects with not enough students. And but if Luca moves into the GE position, then Meredith will probably move into the Thinker Fellow position. And so Meredith was very interested in understanding how companies handle changes in their manufacturing process. Specifically, do they validate and verify after implementation? And after conducting a series of interviews in the spring, she found out that apparently no one that we've found thus far actually verifies post-implementation change management. So that's what her thesis is going to be. The others in the cohort, Chip, he is going off into industry. Shane is anticipating grad school. He got in at 5 different programs, and I have not heard back from him on his final decision. David, or William Jewell, he is heading off to industry. He's very excited about essentially a consulting company. Clint right now is, I think he just started at First Quality in Anderson. Adam Wagner, he did the program kind of, so he was only in the program for the fall semester, graduated in December, and then continued for a non-thesis this past spring. Luis, I had him convinced to stay for grad school and was going to be awesome. And then TTI made him an offer. It's like, darn it. Okay. And then Rohan. Rohan is heading across the street to focus on his ultimate passion, which is automotive engineering, and eventually working for NASCAR. So as a little sanity check in terms of assessing how the thought process has evolved, periodically we'll ask the students to define what advanced manufacturing is. and I am showing two different snapshots. I actually have a third one that I didn't incorporate here. And their idea of advanced manufacturing has evolved from focused on additive manufacturing or just basically manufacturing to start to include a lot more concepts like quality and improvement, which also overlaps with the same definitions I was getting from industry. So we are seeing that in the course of the program, the students are evolving their understanding. We'll see how well they are doing 5 years out, but I have great confidence in them. So over the last couple of years, we've done a lot of these informationals, and I've collected up some questions that people have had. So I can either field questions from you, or I can talk about some of the questions that students have asked in the past. So it looks like Mark has a question. He has his hand up. Or he doesn't.
Sorry, I was on mute just a second. Sorry about that. Yeah, I'm not a student. But I think your last point, I just wanted to reiterate to the students that are listening in a couple of facts. So let's start out with, we've heard the discussion of you're going to get a job or not. So I'm going to start out by dispelling that myth. Let's start out with you are graduating with a degree from one of the top 25 public universities in the country. It is focused on engineering. It's one of the premier engineering schools, particularly in the Southeast United States. You're going to have, if you don't have a job, come talk to me at the end of this, but you're going to have a job. The question is, are you going to be going on a trajectory that you want for your career? And that's what we want to wind up putting you into a position of, because we want more than a job. Clemson is ranked as the #1 placement office literally in the United States, if you look at Princeton Review. So we can find you a job. We can wind up getting you in a path where you're going to be as successful as possible in the directions you want to take as you move forward. Now, when you look at the program Josh has put together here, talking to industry, I will say one of the feedbacks I've heard is saying, it's great what you're doing with students, preparing them for advanced manufacturing. What we find is interesting is they're all taking jobs or getting jobs outside of the area as well. And my immediate answer is to say thank you. If our job is to the point where we have created people that have such high talent and high skill set that you've got people around the country and companies, organizations around the country willing to spend their hard-earned dollars to give you hard-earned dollars, that's success on our perspective, right? That is doing exactly what we want. We're preparing you to be the next generation global leaders. And this is being recognized not just for the people that are in the upstate region, not just for the people in South Carolina, but literally all across the world. So by being in this program, you're going to be in one of those internationally recognized demand areas, and you're going to be at the top of that position going forward. So that's what I hope you'll wind up walking away from this. Again, we can get you a job. First of all, you're going to have a job. You can just relax about that. I know that's a big concern people have, is like, am I going to be employable? You come out of Clemson University and you're graduate with a degree from Clemson University, you're going to wind up getting a job. The question is, are you on the pathway for your career? And this is a tremendous opportunity for you to prepare for the best career for the future. Thanks, Josh. Sorry, I had to just insert that.
Thank you, Mark. So these are, you guys can read these as well as I can read them. Are there any other questions from the peanut gallery?
Yeah, so for those of us who are only really in a technicality, actually still seniors, is there an accompanying graduate level program for advanced manufacturing?
There is, actually. It is, here, let me go down 2 slides. We have the NSF NRT program. And so the NRT includes funding for some students, but it also has so we have fellows that get paid on it, and then we have scholars that participate in the program. And it includes a few courses. We expect students to take courses on collaboration, such as a teamwork class that I teach, courses in manufacturing, courses in human behavior and modeling, and then also big data analytics and computer science. We run workshops for career education planning and professional development. This past spring, we ran a couple workshops virtually, obviously, after post-COVID, and we had folks from BMW that talked about professional or mentoring in a professional environment. And how do you find a mentor? How do you mentor up? So how do you manage your mentor, which is a very interesting thing. And one of the things that the students were starting to latch onto is that works not just for mentoring up in industry, but also how do you manage your advisor? And this is for anyone that is thinking about doing grad school. The most important thing, the most important decision, have I emphasized that enough? But the most important decision that you make as a grad student is who your advisor is. You need to find someone that shares your expectations, your values, someone that will help develop you into the person you want to be, someone that will push you, but someone that will advise and mentor you in the way that you need to be mentored. Okay, so I would not zero in on whether or not they have money. That is the worst decision you can make. Find someone that you are simpatico with, someone that resonates with you. Okay, and even then, you're going to have to help mentor your mentor. Okay, and so that was one of the themes that came out from the industry panels that we were running with the Thinker program. Now, one very advantageous aspect of the Thinker program is that it is developed and run by myself and Lane Mears, and it highly overlaps philosophically, programmatically, and culturally with the senior year program, since it's coming out of the same basic heads. And so there's a lot of overlap. If you are ready for grad school and you just need to get one undergrad class out of the way, this might be a direction and option for you to go. And if you want more information on that, go ahead and email me, and I will put you in contact with Carol Beckham, who can forward you the application process. So we have, like I said, the Thinker Fellows who get money, and the Thinker Scholars who participate in the program. And so far they've loved it.
Hey, Josh, if I could just weigh in real quickly to answer your question. Whoever the student was that asked the question, you can either say who it is, or if you want to email Josh or myself, you're welcome to as a follow-up on this. One might ask the question, well, why don't we have something called manufacturing engineering out there? And I think Josh and I both have gone through a number of times interacting with industry on these things. And when you ask them, they say, in manufacturing, we actually need, you don't find a department of mechanical engineering at BMW or at Michelin or at any manufacturer out there. What you find is the manufacturing, you find the logistics, you find some functional thing out there. And in that, what you'll have is mechanical engineers, industrial engineers, electrical engineers, materials engineers, chemical engineers, all working together on a team because they all bring part of the solution together. Right. And that's the thing you wind up learning. So your question about where do you want to go in terms of graduate degree, or is there some opportunity on top of this? Literally the entire Clemson curriculum would be of value for you. I will say the engineering curriculum on it. It's the thing that I would highlight on that, be of value. The other part is to say, you know, what's happening as we move to more and more technology integrated into manufacturing is you need to be a mechanical engineer and you need to be really grounded as a mechanical engineer, but you also need to know how to translate that into data analytics, into computational programming, into structure and networking, so you can wind up carrying this out in sort of an information intensive world out there. This will be a lifelong journey for you, whether you go to grad school or not. The information you're using in 2050, right? So let's roll out to 2050, which is the point where you're halfway through your career. 90% of you will be working on for companies that don't exist today, working on products and markets that don't exist today, based on technologies that have yet to be invented. So if you're not preparing yourself for the position on a lifelong basis to be continuing to build upon that foundation of knowledge that you've gotten as a mechanical engineer here at Clemson, you're actually wind up doing yourself a disservice. What we want to put you in a position to do is to say, how do you wind up exceeding not only with the technology of 2020, but the technology of 2030, the technology of 2040? Because I guarantee you there is a kindergartner right now that's going through and learning how to stack their blocks up in a way so that they're ultimately going to be doing a startup company that you're going to want to wind up working for. So, you know, this is a competition. There's people in your rearview mirror. There have been people in my rearview mirror and people in my headlights the entire career that I've been going forward. We've got an opportunity here by working together on this interdisciplinary basis to make it so you can wind up being as successful as possible on this in your career. So anyway, I hope that gave a little bit more insight as well.
Thank you. It definitely did. So I guess luckily that's sort of what I want to go for. I want very eventually to start, you know, consulting on new designs as opposed to improving old ones. Do you think this program, do you think manufacturing is the source of a lot of the problems for the technologies that are being pioneered, and that'll be especially useful to me?
That's a great question, and I'm going to cue in on one word you had there, which is consulting, which is, you know, the difference between the chicken and the pig in a ham and egg breakfast is the chicken's involved in it, but the ham is committed, right? So not only do I want you to put in a position to consult on these things, I wanted a position where you're actually able to drive what's happening, not just providing advisory service on it. You may want to be an advisor on it, and that may be what your company does, but we want you in that position of leadership that you wind up doing on it. Now, as you look at the direction and the history of manufacturing, what it's done, this is where that advanced manufacturing word comes out. And where the Germans put it, they call it Industry 4.0. So it's sort of the fourth wave of manufacturing. If you look at how they would define the second and the third wave of manufacturing, that was really in a world where you had a separate engineering department. They would design things and they would plan things, and then they would put that out on the assembly line, and all the job of the assembly line manufacturing was to do the same thing over and over and over. What's happening, and here in the 21st century, mainly around information technology, is that the creativity that enables, and this started with Industry 3.0 and it's going to 4.0, is what happens in the actual manufacturing process is where a lot of the creativity happens, right? And so augmenting that, and where the really important part comes together, gets stronger and stronger. So it gives the power of knowledge closer and closer to that point where you're actually making something. Now, if you look at the course of your career, what's going to happen is that line's actually going further and further and further up the value chain, not only to the manufacturing side, but then the relationship with the customer, right? So you look at BMW as an example, right? So at BMW, there are over 12 billion variants of the cars they produce. Let me repeat that again. You got 12 billion on a planet of 7 billion people. That means you literally could have a unique car design for every human on the planet. That means when you go down a production line, that information that's come from a dealer or from a potential consumer back to you as a customer is being translated and saying this car is exactly just what you want. It's not just the colors you have on it. and the variations. It literally is all the equipment in it, the layout, the design. That's all become uniquely tied to what information is happening on the consumer side now is directly interacting with the manufacturing side. What that means then is, you're standing on a production car, one car comes through every 60 to 70 seconds is about how often they come off the production line. I'm not sure if that's a secret number or not, so it's somewhere in that range. Every car is being sold to some other part of the world. I tell you, the gas cap designs in Japan have to be a little bit different than the gas cap designs in Czechoslovakia. And the people that are doing the work there need the information that they can confirm. Did that work? Does it not work? Have I done the right thing? Otherwise, everything is wrong that goes out there. Every car is different. The only way you can do that is you have a massive amount of things like vision systems, not to replace the people, is to make it possible for the people to say, this car coming through that you're inspecting right now is going to be going into Czechoslovakia. And I've sensed that it has the wrong gas cap on it, or I've sensed that it's got the wrong rim design on it, or whatever it is. Can you double check that, right? And if you look at the picture you have in front of you right here, this goes to being able to sense the connectors inside of the, there's something like 400 electrical connections in a car when you're manufacturing it. Well, electrical systems are different depending on whether they're going to Europe, Japan, or China, right? And we want to make those cars here, but you need to make sure they're all right. Well, if as the person is reaching inside and making the connector, if it can confirm that connector is the right connector and it went in the right place to the right connection, then all of a sudden a little green light lights up on that person's forearm. That's literally what they're doing on that experiment there, where you've got the 3 little yellow dots on that guy's arm, is a system that's sensing what is the right answer here for this specific car. Now that becomes a really information intense problem, believe it or not. Suddenly you need to use all kinds of artificial intelligence, machine learning, digital twin designs of every car created on the fly, gathering that data, saving all that data. All of that is needed. I probably am over answering your question, but that gives you a sense of what kind of problems you wind up working on in the advanced manufacturing world. And you can look at it for the automotive applications that you have here. Same thing in the making chemical industries, making airplanes, making jet aircrafts, making wind turbines and solar cells that would wind up getting deployed for renewable energy. All of those have related problems like that.
So, Nick, to kind of build on that, you were asking, is manufacturing where there's a lot of design? And BMW has their tooling group. So it's a group that focuses on developing new tools. Could be anything from a glove to a wearable device to fixtures or whatever. And their group, it's roughly about 6 or 7 people. They have 450 projects that they complete a year. Whereas you could go over to Germany and you could be a design engineer for BMW and you get to design a bracket and it takes you, a year to design a bracket that is the engine mount bracket. And after 5 years, you get promoted and you could to design the front left and front right engine brackets. After another 5 more years, maybe you get to be in charge of all 4 brackets. So if you like variety, you like the pressure of having to be creative, there's a lot of opportunities in manufacturing to really do in design. Other questions?
Hey, thank you for the answers, by the way. I appreciate it.
Sure.
Real quick, I had a kind of a logistics question. So for those of us in the co-op program, I didn't know how that would work on kind of tie in. For example, I'm this fall, COVID permitting, I'll be starting my 2nd rotation at Bosch. So I didn't know if there was a way to kind of work the advanced manufacturing program into a co-op rotation.
So we have done that. We had actually Luca is doing his rotation for GE, and he delayed it to actually do it over this summer right now. So that's one option, is to look at, shuffling it. Who did you say you're co-oping with?
Bosch Anderson.
Then we're screwed, because Bosch Anderson does not vary whatsoever off of their co-op schedules.
Okay.
But
we could talk.
We'll try and figure something out. I mean, the thing is, like anything in this world, you test it, you see what works, what doesn't. This actually be a good test. So, Mike Mansuetti would be a good person for us to reach out to and say, how do we make this work better? And so if you've got a desire to do that, let's try and work together, Ben. Is it Ben or Benjamin?
Ben.
Yeah, because people have a wide variety of reasons for being in co-op programs. Sometimes it literally is a financial question. And so, we want to make sure that people are able to be successful and not be sort of boxed into something. But let's try and figure that out.
Okay.
Knowing full well the answer might be, hey, we can't. But
yeah,
it's worth trying to figure that out together.
And I know there's also the possibility they canceled summer, and looking good, but with the whole outbreak in Clemson, it's kind of up in the air. So
yeah, anyone that can tell you definitively they know what the situation is going to be like in the fall, that I can tell you they just don't know what they're talking about, because all we can do is, just like Clemson, as you know, we have preparing for a wide range of options, hoping to be together.
Okay.
I have plane tickets in 2 weeks. And I'm still not sure I'm actually going anywhere. Other questions? Oh, Ben, so go ahead and send me an email.
Okay.
And if you know the contact information for the folks at Bosch that you're specifically dealing with for the assignment, include that too. And Mark and I can work on seeing what we can do.
All right. Thank you.
Any other questions?
Yeah, so I had a question regarding, so like if I definitely want to do grad school, and obviously if I'm applying to other schools, then I'll be submitting applications throughout the fall or whatever. How does the possibility of staying on for another year with this program, how would that fit in, like, to as far as the application for that? Or
so one of the things, and this is going to go counter, and probably every other faculty member on the call is going to tell me to shut up, but from my own experience, I stayed at Mizzou for my undergrad and then also my master's. I knew I wanted to get a PhD, but I wasn't positive what the right place for me was. Okay. And so I stayed. I knew people at Mizzou. I found an advisor. We did some cool stuff in virtual reality, early stage submarine, feature-based design, blah, blah, blah. And in the course of doing that additional year at Mizzou, I was able to identify the person that I wanted to do my PhD with, because he was the one that everyone referenced, everyone cited him. He was the top name in the field, and it was at Arizona State. The Simpsons make fun of ASU, but that was the top and the best place to go. So staying here at Clemson for a master's to get a feel on where the right place is to continue for a PhD can be a great thing. Okay? You learn how to do research, and then the faculty can help network you and introduce you to the right people. Okay.
Yeah.
If you don't want to stay for the second year of the master's, this year we can spend the year trying to figure out what you want to do, where is the right place for it, and who is the right person for you to work with. And working with a faculty advisor, even as an undergrad student, can set you up beautifully. It is a role that faculty ideally play, and it's definitely 100% the role that we play up here in Greenville. If that answers
Josh,
your
I agree with you completely on that. By the way, whoever is speaking, if you need help preparing for your application to go to MIT and Stanford, and you decide, hey, sorry, I can't stick around for one more year because I'm going to Stanford. That's kind of like Trevor Lawrence walking in and saying, I'm going to go to the NFL and going to, instead of spending my senior year. Now, that's not to say that Clemson isn't globally competitive as a place, and we would love to have you here. But, if we're able to be in a position where our students are actually getting cherry picked out to the best places in the world, in the top, just objectively, the top ranked programs in the world, that actually makes the program look good. So it helps us recruit further. And, that's good. It's the same thing happens in almost every part of the world. You've got two choices in your world. You develop people so they are attractive as talent by everyone else in the world, or are you left with people that have unattractive, that are talent that have not met their potential? I would rather do the former than the latter on it. So
yeah, I mean, so I have interest in continuing at Clemson, but I just wanted to see how the logistics of that work out, because I don't want to just plan to or just think in the back of my mind, okay, I'll be staying at Clemson for another year after that, and then miss out on all the application deadlines or whatever for anywhere else, and then I don't have like a
year later also. So don't worry about that. I mean,
yeah,
you can apply at both times. Same thing from. Sorry, go on.
Well, I just want to make sure that like I have a solid plan for what I'll be doing at Clemson, or like I don't want to just be stuck here and then not actually have a plan ahead of time for what I'm going to be doing here, and then just have to be okay with whatever I wind up with here.
Yeah, no. That be okay is not what we're looking for. And we will work with you to make sure that we find the right thing and help you ask yourself the right questions.
Yeah. And this is not it's not a perfect sports analogy. It's almost like we want you to swing for a home run, but if you miss, you're not going to strike out and go back to the dugout. You're going to get to go to first base no matter what. So let's try and get you into that position.
Yeah.
And we can also help you contextualize. Do not go to Stanford or MIT if you want to do engineering design research. There are better schools out there. Just saying.
All right. So my other question was regarding class signups. So I believe Dr. Summers, you said that it was maybe like in late June or last year, at least that's when you guys like signed students up for classes for the program.
So
do you have an idea of when that's going to be, or?
It will be soonish. What we wanted to do is we wanted to finalize the final set of students, and that was part of the goal of this, to make one final push to see if there were other interested parties that we missed because of COVID. That was our biggest concern. And I'm going to give everyone another week or so to think and ask more questions, and then we'll start populating. Because part of the challenge is I have to go through every student individually and verify what classes they still need to take, if they're not perfectly situated and lined up. And so we'll work on that in the next few weeks. Don't panic. We have you covered.
Yeah. Now, one advantage, Josh, depending on how things play out with COVID, and nobody knows the answer to this yet, but in one scenario where we're limited in terms of class size, but you want to have that in-person interaction, the option of being in Greenville, we actually are set up with very good connectivity back to the main campus, so people can be giving remote lectures and things like that. But we also have individual cubicles, for instance, where all of the students that are there on site will be able to actually have an isolated cubicle. So there's a way to wind up sort of dealing with this this sort of, what do they call it, a hybrid scenario potentially in the fall. Again, no one knows exactly how it's going to play out. We do have a plan for everyone to wind up being together and then having optionality for what might happen in other scenarios as well. But you can see where the you know the ICAR facility actually is a nicer environment relative to other options people might have.
Yeah, from that, did a network analysis comparing students from last fall in the cohort versus students in the similar class on main campus. First order interaction average, person to person, was 22 students here in Greenville, and it was 100 students, or no, 280 students down on main campus. Second order, which is what most of the epidemic or the pandemic models are actually dealing with. Second order students on campus interacted with 10,000 students, whereas up in Greenville, we had maxed out at 300. So likelihood is drastically reduced just here in this program. Now, if you go out to the bars, that's a completely different story. All right, any other questions? Nick? You unmuted.
Yep. Oh, wait.
Nick Kilbarger. Not hearing anything.
I have a question.
Is my mic working now?
Yeah, Nick,
Yeah.
you are working, and Ryan, I'll get back to you after Nick. How's that?
Okay, yeah, I just had a quick question regarding the tuition. So is this still standard Clemson tuition, what we'd be seeing for senior year, or is it something like the automotive engineering certificate program where it's a extra cost on top of that?
It's the exact opposite of both of those. So if you are in the program, you pay the regular tuition and you're eligible for a $2,500 scholarship.
Okay, gotcha. I remember seeing that number,
Yep.
but I just don't remember seeing the cost. So that explains that. Appreciate that.
And
We don't
Josh, if I can explain that just a little bit more relative to that for the students here. The state of South Carolina knows that advanced manufacturing is so important for the economic future of the state of South Carolina that the state actually makes investments in research, education, and outreach. And so providing those resources actually are funds from the state of South Carolina intended to try and increase the participation in programs like this. So, it's not Josh and I that are writing the check, by the way. It's all the taxpayers here. So, thank you.
Yeah, my portion of the check is a penny or something. So, all right, Ryan.
Yes, sir. I'm just curious about what is like the class and time load as far as like class time in Greenville.
Like the schedule or the
well,
workload?
just like, I guess sort of both. Like what would be like the added time? Like I know that senior year is generally project based anyways. And I'm just curious about like, what could I take on top of this program? Or maybe I shouldn't take any more if I am in this program, because I'm really interested in it, but I'm also interested in a couple of other things I've been looking into. So I'm just trying to figure out the logistics of that.
So to kind of put this in context, I'm going to tell you about some of the students that were in the program last year, okay, and what they did beyond. So we had one student in addition to this, did a automotive certificate. Another student continued and did a business minor. So he had one class in the fall and one class in the spring. Another student, I think it was Jasmine, worked on a German minor, or she just took extra German classes in the fall and spring. We had two students, I think it was two, that were also RAs in the dorms. So they were able to make it back in time for their duties. Now they kind of got screwed because they weren't there during the midday, so they got more of the late evening shifts, but they were extremely happy with it. Don't recall anyone that was Greek in that cohort. Try and remember, but we did have several that were actively participating in this case, most of them were only participating in one like club on campus in the evenings. So if you wanted to do a minor, if you wanted to work on, working, there were several that were working part-time while they were doing this. If you wanted to continue engagement in extracurricular activities, that was fine. Most of the students wound up taking the shuttle bus up and back. And that actually was great for them because that created a hard stop on my lectures on Monday nights. They had to make the bus, so they just told me to shut up a lot. And I think, does that kind of help answer your question?
Yeah, it absolutely does. So I was looking at like I still have some requirements for my math minor.
Right.
And I was looking into a couple of other things, but yeah, that definitely answers your question.
One thing also that's relevant to this, and we should get the list of class on that, is that in the same building on the ICAR campus, literally on the other half of the floor, computer science is setting up a BS/MS program as well in the area. And so if there are courses, especially if you're talking about like a math minor, they have courses on things like, some data analytics, but also machine learning, artificial intelligence, courses like that they're starting to offer that are, I believe, at this 4,000, 6,000 level. So, the vision in the long run is that you have that sort of information technology opportunity as electives, and a lot of those in the advanced manufacturing area. And that reflects the fact that a lot of the, sort of companies out there say, we need people that are mechanical engineers, but they need to program as well. And they need to know how to build robots, and they need to know how to program the robots and all that sort of stuff. So that's kind of the direction it's going with some of those alternatives. But I don't have the explicit list right now. We can probably get that for you, Ryan.
Awesome, thank you. I also have one more question. Are we going to get a recording of this meeting? Hello?
Josh, that's on you, man. You're the one that's recording it.
Sorry. I was talking. I was muted. Yeah, the goal is to go ahead and generate and make that recording available to you. It's going to be in Microsoft Stream, so I have to do a few conversions and everything. But hopefully by tomorrow night, I should have something posted and available.
Hey, Josh, if I can suggest, we're right at 8 o'clock right now. First of all, I want to thank everyone that's joined us here. Perhaps what we can do is take some wrap-up moments now, and then if anyone wants to have a conversation afterwards, we can wind up doing the sort of postscript.
Yep, definitely. I still got to drive home tonight to Clemson. So any final thoughts, Brian or Geeta, Mark, that you want to share? Or
This is Brian, and just want to emphasize that indeed, just by your attendance and your questions of attending this seminar, you're investing in your future. Earlier, I was asked in terms of input for this seminar and so forth, and I was a little sheepish to say it, but I will say it at this point, and that is, I'm a baby boomer. And so in terms of my career length and so forth, I have come further than I will go in terms of remaining time and career. So this opportunity that everyone has talked about and emphasized in terms of preparation for your future, I can't overemphasize how this program will just put you in position to enter an organization with significant baseline knowledge, to establish your own company or consult or graduate school. Everything that's been said, I second the motion, having been in the channels this past year and having worked in electronics industry, having worked in the automotive industry, having been in academia, prior to this assignment. So just another flag or emphasis to say that thanks for joining, and I'm certainly open to answer any questions and be available, and hopefully this will lead you to enroll and participate in the next cohort.
Hey, Josh.
Is it Dr. Kilcar?
Yeah, I wanted to tell all students that if they have any questions about their overall AME curriculum and how this fits in that, or anything that they're confused about, you can contact anytime our undergraduate director, Dr. Edward Schweisinger, or even graduate director, Dr. Paul Joseph, Associate Chair Gang Lee, or even myself. So please feel free to email these people. And of course, Josh is there to help you out with all the AMFG side of it. And since you will be getting a ME degree, and if you have concerns about am I on the right track, everything fits well in my timeline, and you need to chat, just don't hold back. Shoot an email to these people and schedule appointment and get everything clarified so you feel comfortable. And thanks for joining. I hope you can join this program.
Geeta?
Yes, I would like to add like 2 sentences actually as a last note to kind of add to what Brian was talking about. So it's two examples actually. One was when we went to a trip to Hubble Lighting. I think it's the vice president who's helping us with the tour, and he was like, "How can I get these students to take internships at my company?" So you can see the opportunity right there. One, and then the second example I would like to share is once our capstone project was done, I received an email from the personnel at GE saying that, you know what, we want your students, like students in this program, to do more capstone projects for us. So when will be an opportunity for them to participate again? So you can see the opportunities this program would open up for you, I guess, just from those examples, I'm hoping. So those are the last words. And one more, Ryan is in my 3040 class this summer. Great to see you here. Yeah, that's all I have. Thank you for your time.
Thank you.
Nice to see you as well, Dr. Shimada.
Hey, you can call her Geeta when you join the program. You've joined. Call her Geeta.
All right.
It's hard. My own grad students still don't call me Josh. All right. On that note, I think we'll wrap it up. If any of you have any other comments, questions, concerns, feel free to email me. You have my contact, or Brian or Geeta. And we look forward to moving forward. Take care.